Good afternoon and welcome. Thank you for joining us for the next session of our InSource Virtual SI Lunch and Learn series. My name is Katie Schauer, and I am the Digital Marketing Specialist here at InSource and your host for this afternoon. Just a few housekeeping items before we begin. First, we are recording today's session, and we will be publishing that at a later date and sending you the recording. Second, if you have any questions during any point in the presentation, please use the Q&A or chat boxes, and we will answer all questions at the end of the session. And with that, I'd like to hand it over to Aaron Evans.
Thank you, Katie, and good afternoon, everyone. Welcome to the third session of our Digital Lunch and Learn series. These sessions, for those of you that are joining for the first time, are some knowledge transfer events that we plan to hold with you all in person. And to also bring you lunch while we were doing it. But like I said before, COVID happened, and therefore we're bringing this to you digitally. If this is your first time joining, we've already had two sessions. The first sessions covered what's new from AVEVA. We talked about how AVEVA is driving digitalization from edge to enterprise, including some information on the exciting new 2020 release of InTouch System Platform and their cloud offering. Last week, we learned about model-driven MES, the asset performance management, and unified digital engineering offerings from AVEVA, which was also very exciting. Now today, also in those sessions, Tim Black, who's the Global SI Program Director, shared some news about some enhancements that's being done to the SI Partner Program that I think many of you will love if you haven't heard about it before. This includes new programs for our SIs for the MES, APM, and engineering offerings I just spoke about. If you're interested, please feel free to contact your local account executive if you want to learn more, or you can post questions at the end of this session if you have any specific questions about those programs. Today, we're going to take a deeper dive into the APM, or the Asset Performance Management offering, and really learn about the exciting predictive analytics tools that AVEVA offers. These tools are easy to use, and they go from very small, easy to install, easy to use, all the way to doing some really complex mathematical design kinds of things to give more in-depth predictive analytics. So you'll learn about that today. And this session will be followed by a few other exciting knowledge transfer sessions. So next week, we'll take a look at edge solutions offered from InSource, AVEVA, Stratus, and Advantech, and that will be followed by a deeper dive into 3D laser scanning. Then we'll talk about mobile computing capabilities that support things like paper on glass and workforce optimization solutions. And we'll end it with a webinar on IT infrastructure. As you know, all the software we provide runs on some IT infrastructure, whether that's PCs, thin clients, networks, fault-tolerant servers, videos, and closures. And we'll share some options and best practices to build a solid IT infrastructure solution to support your client's edge to enterprise options. So with that, I'm going to turn it over to Justin, who's going to tell you a little bit more about the predictive analytics offering from AVEVA.
Fantastic. Thank you very much, and welcome again. I did a brief presentation last week on the overview of the channel-ready AVEVA Asset Performance Management portfolio. If you didn't attend that session, my name is Justin Thomas, and I'm leading the global effort for enabling our partners that include systems integrators, distributors, OEMs, global alliances, and so on, enabling that group of partners to be channel-ready with our technology. And then with me, I've got Omar, who's our technical sales consultant in the Americas, and he's going to do a demonstration. So I'm glad to be here. Thank you so much for taking your time today. I know that most have taken a long weekend because it's Memorial Day weekend, so thank you very much. I'm going to get started here. And again, I just want to get started with just a quick 2-minute, or let's say 30-second overview of the AVEVA portfolio, just to set the stage here. So at AVEVA, we have technology that really helps us transform the way in which work is done. And we look at it across the operations and asset life cycles. So that means when we think about an asset, we've got to start from the very beginning. So for greenfield facilities, we've got software that enables EPC contractors to fulfill their obligations through a data-centric approach. as opposed to a document-centric approach. And then we do this data-centric approach to help the engineering design, the construction, the commissioning, and handover to be much more seamless and streamlined and collaborative. So we've got a lot of rich domain experience here in the engineering part of the circle here with digital twins, 3D models, digital P&IDs, digital work processes, again, moving from a manual and paper-based and document-based to a digital and data-centric based model. And that helps to fundamentally, for engineers to fundamentally complete projects on time and on budget. Then once that project is handed over, we really focus around operational excellence and asset performance. So those are the other two parts of the portfolio. And then today I want to focus on performance. And there's 4 pillars within performance. We've got strategy, that's building out how we're going to maintain the equipment that we have. How do we develop a criticality and maintain that or understand what the criticality of the asset is, and then understand the risk of that asset to the business in terms of risk, cost, and performance on that asset. If it fails, what's the potential impact to the business? Or if it's in an e-stop condition, how that might impact our OEE. Then from an information perspective, we like to collect all the different types of data sources, whether it's engineering information, operations information, or asset performance data, maintenance level information. We collect that both in real time as well as periodic type of data. And oftentimes this is a real interface to the existing infrastructure that you guys are used to with the SCADA systems, InTouch, MES, system platform, Wonderware Historian, but also the third-party software and technologies as well. We bring that into a common platform so then we can make sure we're staying with our maintenance schedules, but then we can utilize this information for analytics, which we're going to talk about today. And then the other piece of that is then executing on the information that we have. We have a strategy. We got the data that supports the strategy, so we've got a single source of truth. We've got analytics that we can feed that data into, again, from the existing infrastructure to third party for us to understand with early warning what potential failures are occurring or what the impact is to our OEE. And then we take execution on that. So once we understand what the problem is, what the remedial actions are, then we can send that and have it executed in the field with standardized, digitized procedures and digital workflow. So like I said, today I want to focus on the analytics part of the APM portfolio. And when we talk about asset performance management, we really look at it as a journey. We understand many utilities, many plants, many manufacturing facilities and such. Most of the maintenance is based around time-based, more preventive strategy. Every 6 months perform a lubrication event, for example. But doing that really does not allow you to detect the failure patterns that are occurring in real time based off the condition of that asset. So what ends up happening is you end up spending more money. You're most likely over maintaining that equipment. And so what we look at is, again, defining that criticality of the asset and the importance to the business based on risk, cost, and performance. We then try to look at over on the right-hand side here, where's the opportunity for us to do better, right? How can we improve the way in which we maintain equipment? And so there's different pillars, right? We've got reactive maintenance, which is run to failure. We've got preventive maintenance, which is planned, calendar-based. When we move into more real-time aspects where we've got sensors that are monitoring the condition or the health of that asset, and we can build rules to alert for known conditions associated with that process or with that equipment. But we can also, for more sophisticated, more complex machines, more complex equipment, we can apply sophisticated machine learning and artificial intelligence in order for us to become more proactive than we can with fixed time-based, either fixed time or fixed condition based on rules. And then when we have a nice combination of all of these 4 that we just talked about, the most comprehensive strategy has a mix of all 4 of these, depending upon risk, cost, and complexity of the business. And so we've got a couple different ways in which to be predictive. First is we got to get the information into a data platform so that we can perform analytics. So oftentimes a real easy way to do that as part of the AVEVA platform is through Insight. So this natively plugs into, again, the existing Wonderware technology, existing whether it's, again, the MES systems, InTouch, System Platform, Historian, eDNA. It also plugs into third-party technologies, but the connectors are built into the to Insight. So it makes it real easy to bring the data in. Once the data is published, we have technologies that are automatically going to start learning on that data, and I'll explain that on the next slide. But native into Insight, which is our IIoT, or Industrial Internet of Things cloud platform, we've got management of your plant sensor data, again, published into a cloud space. Very, very popular right now for remote working and team collaboration, given the state that we're in. Reporting and analysis. So we've got embedded tools for you to build reports very quickly. This is more of a self-service platform, doesn't require any training. Very easy to click around and learn. Again, making it easy to do business for you and for you to help do business with your customers. So we've got condition-based maintenance built in. So we've got a real easy way to click through, and Omar is going to show you how we do that quickly in our demonstration. So again, that's native to the software, comes with it. OEE, measurement and reporting. I'll show you quickly on the next slide what that might look like today, but it's the ability to very quickly within a day, you can start collecting the downtime events and the reason codes. And instead of spending, a lot of rigor with consultants, you can go in and work with your customer and get a very good measuring stick for your OEE right within Insight, so that you can use that as a basis to figure out where the problems might be. AI-based predictive and prescriptive maintenance. So artificial intelligence is, again, as I said, it's native into the software and fed through what we call newsfeed. You can see here up in the upper right corner here, you see news. What this is really an anomaly detection that tells you when there's something that's unusual with a sensor or with a group of sensors. We've got connectivity to prescriptive maintenance, not today. I would say that would be coming out this summer. And that's what we call our connected content. Again, that's related to Insight, allows you to look at the prescriptive actions associated with a newsfeed, for example, that might be populated. So not only is there an anomaly, but it tells you what the potential problems might be and what the remedial actions would be to resolve that problem. Asset strategy optimization. It's not native to Insight, but is connected right to it, again, through an additional module. And that will help you to define your asset strategy, maintain that asset strategy, and continuously improve the asset strategy. And then very easy to connect through a secure transport layer. Single pinhole through a firewall makes it very easy. Actually, within an hour, you could have data being published and working with your customers' data. Anomaly detection, again, it's artificial intelligence built right into the software. As soon as the sensors are pulled in or published into the platform, it will automatically start monitoring for deviations. So it will look at it and determine a time frame for which there's abnormality that's occurring. You have to do nothing. It just automatically starts looking for it. And then you make the anomaly smarter by giving it thumbs up, thumbs down, telling the software whether it was useful or not. So here you can see temperature has been lower than it has been over the past 2 days, as you can see here in red. The wind speed is higher than usual, and so on. So it kind of gives you, the operator, for example, a little nudge to say, hey, let's take a look at this quickly to see if we need to adjust a set point. The other thing that's built in that's really nice for food and beverage manufacturers or discrete manufacturing is looking at OEE and the performance related to that. So again, today we manually enter in the downtime events and the time and the reason codes, so that we can start looking at this from a KPI perspective on, what's causing the downtime, so we can continuously improve. We have the visibility now for the operators and the engineers and the managers to all have a common source to look for this information. So, operations isn't telling engineering, and engineering isn't telling operations, and operations isn't telling maintenance. Everybody's coming from the same page. Next release, that'll be coming out automatically, so we don't have to enter in the reason codes. And the other piece here that I would just want to address, again, that's native to InSight, is there's different ways of looking at machine learning, all of which is a component of what we call artificial intelligence. One way to look at it is a supervised machine learning. Again, a supervised machine learning means that you've got a human that guides or configures a model that will enable the software to start looking at a group of data and a group of sensors associated with that data. It will build the correlations and modes, if you will, of operation automatically, but you need to point it to what to look at. And then it'll identify the outliers once you point it for what to look at. And you can think about a bunch of sardines floating through the water, all swimming nicely together, and then there's one or two that go out of the path. That's what the software is going to do, identify those types of outliers. We've got two different forms of this. One is Prism. We've been in the market for over 10 years. This connects to the InSight platform. So the InSight is the data source feeding into this predictive analytics application that used to be called Prism. And then we've got another one called Advanced Newsfeed. This is native into InSight. And sorry, screen moved on me. And it doesn't require any model cleansing. I'll show you here in just a second with that screen that just popped up. The idea here is, again, you point it to where this the group of tags that you want it to monitor, and it will automatically build the model. As you'll see, what Omar is going to show you is there's differences. I'm going to show you how to build one here, and you'll see briefly how to build a model potentially using Prism, which requires a little bit more of cleansing, if you will, within the model. And the other part is unsupervised. This where you don't do anything. Once you publish the data, the software automatically starts configuring itself to look for anomalies. However, it may report more insignificant discoveries because we haven't given it any boundaries. There's no football field, if you will. Where are the goal lines, where are the out of bounds, and so on. We're doing that with a supervised machine learning technology. Okay, so the unsupervised is built into InSight, as well as unsupervised machine learning in different forms. Advanced newsfeed and regular newsfeed. And just let me show you quickly here what that might look like. So again, this is what we call supervised artificial intelligence, and you can see that down here in this panel where it says supervised AI. And we can build these supervised AI models through a very easy point-and-click interface. So from this asset display, we select Add Supervised Artificial Intelligence Algorithm. In the future, we're going to have multiple available. Today, we just have the anomaly detection algorithm that's available. So we select that particular algorithm. And when we select it, it'll allow us to then select which tags we want to look for related to this particular equipment. In this case, in this demo, we selected a reactor. For that reactor, we've got a valve level and a temperature that we want to look at. And we can see that in the summary. We click Next, and then we give the model a name. We're going to call this a reactor performance model, and then a start date and an end date. And in this case, we're just going to pick 3 months of data for the software to train under. So again, we're pointing it to a set of tags and a set of data to learn what the normal behavior is. And once we do that, we get the summary, we click Save, and there you have it, really. Once we've saved it, what the software will do is automatically learn what the normal behavior is, the normal operating regime or the characteristics that are associated with those 3 tags under any type of condition: high loads, low loads, partial loads, ambient conditions, and so on. We can also make modifications to this model if we wanted to. If we click on the reactor performance, it will actually tell us, it gives us a summary. We can update it, if we'd like. So makes it easy to make changes. But when it's live, you see the newsfeed here, and what it does is it gives you a score of the anomaly itself. So how severe is the change? And from there, what we can do is drill down. And when we drill down, it tells us that the Austin reactor temperature is really the anomaly that's causing this high score. So from there, we can do our analysis. So that's how easy it is actually to configure a model that uses this advanced technology. But what I want to focus on today is more the sophisticated predictive analytics that uses the supervised machine learning that used to be called PRISM. This technology has been out in the market for over 10 years. We've got over 40,000 assets that are currently under supervision using this technology. And again, as I explained, it uses artificial intelligence, leveraging what we call advanced pattern recognition, and it will continuously monitor behavior in real time once the models are configured. The idea is, like we were showing before, is to detect and diagnose problems related to equipment early enough so that we can take a proactive approach of either maintaining the equipment or taking action so that the degradation of the maintainable item doesn't further deteriorate, or we look at the performance of the line and making sure that the performance doesn't further erode. So we don't cause downtime or erode the asset performance. It's model-based, so the idea is we're looking at groups of tags associated with an asset, a piece of equipment, or a process. And then once we understand those anomalies, then we can try to check to see if it's associated with a given known fault pattern. And the idea here is it's different than condition monitoring because we're looking at anomalies that it's just really not possible to build a rule around. We're trying to identify those outliers again. Maybe we're not understanding what that outlier is, but after further diagnostics, we can determine that maybe it is associated with a known fault condition. So we're able to kind of cover the full spectrum of the anomalies. It uses historical data in order to train what the equipment normal behavior is. So that might be 3 months, it might be 6 months, it might be 2 years worth of historical data. Really just depends on the behavior of that asset and how much it changes over time, or the types of batches it's associated to and how that changes, or different products and how that changes over time. The alerts happen when it deviates from the operational norm. So this isn't a fixed set of rules. It's constantly changing depending upon the operational health of that equipment and the condition of that equipment. So the alarm conditions change over time. So it's a dynamic set of alerts. And again, these are alerts prior to the distributed control system or SCADA system alerts. And then along with this, you get a set of diagnostic capabilities. So not only just an anomaly detection, but then what's the potential fault characteristic associated with that? What's the likelihood or confidence level that it is that fault? What are the remedial actions associated with that? And then how does that benefit? Well, obviously, if you get early warning, you can take planned proactive action. So it helps to improve your asset reliability and performance. Helps you to reduce maintenance costs because you're not performing maintenance on a time-based or calendar base, and you're being much more proactive. So you're not doing emergent work, and you're not over-maintaining your asset or under-maintaining it for that matter. It's more idyllic. In terms of the planning process, because we have more visibility and we understand the criticality and the importance of that asset, which will be described here shortly, we can then plan on when to take that proactive maintenance at the most economically opportune time. And then we talked about diagnosing the failures and prescribing actions, but these are purpose-built, and this is designed specifically for industrial assets, assets in manufacturing facilities, assets in heavy industry, and assets even in mobile equipment. And it's holistic, so that means that it's not first principles based. We don't need engineering equations or pump curves in order to understand, in order for the software to work. In fact, it's much easier to use because it's based on data-driven, sophisticated machine learning. And because of that, it applies to all different equipment types. So we don't have to have one specific model for each unique type of compressor. We don't have to design these compressor templates for each unique type of compressor. The model will be unique, but the templates are generic, which helps us to very easily scale software and scale to your business. So compressors, pumps, motors, gearbox, distillation towers, spray dryers, conveyors, furnaces, heat exchangers, all sorts of different types of equipment in the line. What we're trying to do, and I described this a little bit earlier, is get us higher up on what we call the PF curve. So on the y-axis is the probability of failure. On the x-axis is the time it takes to fail. And then you can see this curve here, and you can see how the symptoms occur on these types of assets. And typically when a equipment condition is identified, it usually takes between 2 and 8 weeks to repair. And the longer you wait until you identify that problem, the higher the cost is to repair. The earlier you identify it, the lower cost it is to repair. And so the idea here with this predictive analytics is to catch this, the symptoms that we call anomalies that are occurring in advance. When I go to the doctor, the earlier I go to the doctor and the earlier we're able to prescribe potentially some medicine to take care of that problem, then the better chance we have of getting healthy sooner. Same thing with this equipment. We got to look at the signals, the sensors. It's telling us something. Whether or not we've got the technology to be able to understand and absorb it is different. Depends. And so that's what we're trying to do with this predictive analytics software. The further we can catch it, the earlier it is on the y-axis or x-axis, and the less cost it is to repair. So what does that algorithm look like? So what we do with predictive analytics is a little bit different than what we do with traditional alarming. With traditional alarms, it's set it and forget it, right? High and low thresholds, you put a box around the data. If the data falls outside of that box, we get an alert, actually an alarm that says, that's most often connected to an asset management system in one way, shape, or form, which then trigger a work request or a work order to go triage people to go do something. But inside the box, there's, we're considering it, inside these red box, we're considering it to be normal. So that's the standard way to do it. With predictive analytics, what we're trying to do is to identify what those operating modes are that are normal, which are identified here as these blue squares. And each one of those squares represents an operating mode for that model. And that's what the machine learning technology does. It learns how many of those boxes and what the dimensions of those boxes should be. And this is only a two-dimensional shape here. But in fact, these models are n-dimensional. So if you've got 15 sensors that you're using in a model, that's a 15-dimensional object that the software is looking at. For this case, we're just using 2 dimensions. When we get something that's an outlier that falls outside of the blue boxes, that means you're going to get an alert. And that alert is either normal or abnormal. We don't know because right now we've got to do some investigation. And so we call that a new operational situation. And we can either retrain the model because we say, well, actually that follows along the curve here. Maybe it's a hotter day than we've seen in the past year. So we'll consider this to be normal and it's not too far deviating. So then what we just do is click retrain. However, when it starts to persist or be sustained outside of the normal, then we know that there's likely a problem. And so in a traditional sense, we would say the DCS alarm is set at a fixed threshold of 155 degrees C. Well, you can start to see that there's a pattern that's emerging that's under that 155 degree curve. So this is where the additional value of these predictive analytics comes into play, because we're able to identify the anomaly, early. And what we can see here is as this persistence starts to increase, the residual that we have here between the actual value and the software's predicted value start to increase. So when that residual increases, we can say, okay, how much time do we really have to take planned corrective action? Because if you draw an extrapolation here, just on this curve, you can see that we probably have at least 3 to 4 weeks of early warning for us to take some action. I've talked about it's holistic in its approach, so it covers the whole plant. Whether it's we cover the whole plant using our sophisticated predictive analytics, or we cover the whole plant using our condition monitoring along with predictive analytics, along with newsfeed. The idea is the software can cover end to end. And again, depending upon what the strategy is, not all types of equipment are going to require predictive analytics. If it's a run to failure consumable type product, you're not going to put a predictive analytics software on it. So any of the technology or any of the equipment in the plant that is highly complex, it's something that can be applied to our software. Okay, so once the models are configured, then from a user perspective, there's a user interface. It's web-based. It's real easy to access remotely or while you're on a facility. A lot of times we see as we scale to an enterprise type approach, the alarm capabilities and alarm and alert capabilities and able to manage those alerts is very important. Omar is going to do a demonstration here, so I won't spend much time, but this is the user interface for someone that's going to be doing the diagnostics. There's alert workflow that's built in. So when you start to get thousands of equipment that you're monitoring, it's very, very important to have an alarm management or alert management built in. So we have that very easy to categorize what those alerts are when there's an action that needs to be taken and escalation towards those actions if they're not taken in a period of time, what the status is of the model is when you're clearing the model, what category are you going to put it in, and is there escalation and so on and so forth. Who do you want to assign the alerts to, and so on. So that's all built in. It's very, very important for very mature products to have that, and that's what we've got. And it's a differentiator between someone else that comes in and says, well, I've got a Microsoft Azure platform, or I've got a very specific valve monitoring solution. This is more holistic. It takes into the valve monitoring solution. It also takes into the rest of the plant, and it's purpose-built, fit for purpose with templates. So you're not building your own in the IoT platform with a machine learning algorithm. This is already pre-configured, pre-built, very easy templatized. You can go in and just smoke the competition because of how easy and quick you can build these models. Once you identify that there's an issue, right, we click on it and it pulls open and automatically populates this display. You can see on the left-hand side the tags that are in this particular model. This looks like it's a pump model here, a motor-driven pump. At the top, we look at what we call the asset health. We call it overall model residual. And at the bottom, there's all the different trends to be able to identify what that problem is, and then the fault characteristics associated with it. And then you can see the confidence level in each of the potential fault modes here in the middle. And we can see that thrust-bearing temperature is the most likely. And then from there, we can also get the description of the fault, the severity of it if we don't take action on it, as well as the next steps. That's the remedial actions. We've also got something we're coming out with, which is called remaining useful life, which will actually forecast out into the future when that failure mode would actually fail. That gives you the time to plan for corrective action or plan maintenance. And then lastly, collaboration and knowledge transfer. So this is a way to enter in to the software the knowledge gap. So what did you actually do so that you can make the alert searchable or the event searchable. So in this case, we had a booster pump issue with some lube oil contamination. So we enter in what that event is. It's tagged to that particular model, but it's also stored in a database, which makes it a library of information that can be searchable. We just talked about this. So this is just about the prescriptive maintenance. So it's a three-step process. First, you get the anomaly. From the anomaly, you get the fault characteristics and the fault diagnostics. From the fault diagnostics, you get the planned corrective action, the remedial actions that are pulled from all of our years of knowledge, 20 years worth of knowledge in the industrial space. So we're kind of linking that knowledge together with these early warning detection. And basically, I'm going to just talk about this in one reference, and then I'll hand it over to Omar. So we've got a lot of different references that are out there. As I said, 40,000 industrial assets across different types of industries. We've got mining, we've got power, we've got chemicals, we've got oil and gas, and all upstream, downstream, midstream. We've got across the world, obviously, different continents. We've got food and beverage, different types of food and beverage, both CPG as well as manufacturing, batch processes. So lots of different exposure here. And I'm just going to do this real quickly. So when we've, again, given our, a decade of experience, we've really had a lot of different use cases. We've helped different types of conditions to be able to monitor and detect. So in this particular case, we're looking at, how do we prevent outages and the number of e-stops that occur to keep these lines running. So we helped to reduce the amount of inventory that was required in order to maintain the equipment reliability. As you know, asset reliability is one of the components of OEE, so it's super important. So you can see the change here in the amount of inventory that was reduced by using this as a strategy within their manufacturing facilities. The other one here is about, making sure that if there is product available, that you're producing the product, so the lines are running efficiently. So we want to make sure that you're not in a starved state. So if there's no product available to be made or packed, or a block state where there's product available but it can't be packed. So we want to make sure that we're as efficient as possible, and they're using the software as one of their strategies to make sure that they can keep an eye on it with an early enough warning that they can take proactive action. And then this is just a real example of a wind turbine. So in real time. So you can see on the left-hand side, these are the tags that are used. On the upper here, this is actually the failure mode. There's an 84% likelihood that in this case it was a bearing issue, a generator issue with the wind turbine. And we can see down here how the software was able to detect it, and they were able to take corrective action to save the wind turbine bearing from failure, wind turbine generator bearing failure from failing. So we've got a lot of experience, as I said. We're proven, and we've got proven results. We've got a long-term vision using this software, and we're actually now infusing this artificial intelligence inside of our software. So you're going to be having smart searches using AI, right? So we're not just exposing it to your customer, but we're also embedding and infusing it into our software to make our software more intelligent and easier to use, making it more the 80-20 rule. So it's more software and less configuration and less customization of the software, and allows you as systems integrators to do more configuration work and make it easy as a step-by-step template. A very broad customer base, as I just talked about. We've got a lot of successful projects we've executed that started small and grew to an enterprise type solution. So we started from a production line at a plant to a full plant to 10s to 20s. We've got some facilities that have 129 plants online. We've got some chemical or like Air Liquide, for example. They've got close to 200 sites that are on board right now from a single monitoring platform. So very, very scalable. And then we're open and agnostic. So it's not a one and done type solution. We realize that we're part of an ecosystem of technology. And so we've got KPIs or APIs that make it open. So with that, Omar, I wanted to pass it off to you. Yeah. So that's up to you, buddy.
All right, Omar, you're all set to go.
Thank you, Justin. Thanks a lot. Can you guys all hear me okay?
Yep, we can hear you loud and clear. And just don't forget to share your screen. There you go. Perfect.
Yep. All right. Well, thank you, Justin. Thank you, everyone, for spending some time with us today. Like we mentioned a little earlier, we know that it's a Memorial Day weekend, and so we're fully aware that you guys probably have some long weekend plans. So thank you again for spending a lot of time with us. Really appreciate it. So Justin has done a great job of really sharing with us the APM story and the APM journey, and we really don't need to remind any of us of this situation, but with the impact of COVID-19, now more than ever, our customers really need us to help them with maintaining their assets more securely, more remotely, and more collaboratively than ever. And with APM, we enable them to do this. So really, we can start in talking about how APM starts in motion, from starting us off with criticality, leveraging our asset strategy optimization solution to identify and prioritize the investment of certain assets based off of criticality. From there, we can decide which type of analytic solution we can implement. We can utilize one or more of these solutions. So what you see in front of you are the various analytic solutions among many that AVEVA offers. And Justin really talked about quite a few of them, from newsfeed AI to condition-based maintenance, to advanced newsfeed, to, of course, our specialization for today, supervised machine learning, which is predictive analytics. We can leverage all those analytic solutions and tools to really try and understand the story that your assets are trying to tell you. From there, we can leverage that information. We can leverage that maintenance procedure over to our EAM to really try and manage those work orders and work requests to better maintain your assets and act upon the information that you have found. What's really modern with AVEVA, though, is, of course, leveraging the cloud and AVEVA Insight. And that's really what I want to talk to you guys about today and show you in my demo. What I want to go through is show you a variety of these products together, really leveraged by AVEVA Insight, and showing how the cloud is now really the skeleton that we're using. But of course, I'm going to be specializing a little bit on predictive analytics mostly. So what I'm going to be doing for you today in this demo is playing the role of an operator in a brewing facility or a brewing plant. So really kind of leveraging the food and beverage example. We'll be talking about from beginning to end how we can leverage those insight tools, those analytics tools, as well as specializing in predictive analytics to really try and better maintain your line, your production line. So without further ado, let's go ahead and get started. So I, as an operator, get an email notification. Right? And this is the type of email notification that I would get. And this email notification is from AVEVA Insight. And it's notified me that I have an alert and I have a fault with my line, with my production line. And if we scroll through this email notification a little bit, you're going to notice that there is quite a bit of detail with what exactly is going on, what my availability is like, what my downtime is like. This email notification was generated by our CM application, our CM maintenance procedure. It's a rule-based application, and then a little bit later on through the demo, I'm going to show you how exactly we can configure that rule so that we can get this automated threshold, this notification that can get us started with our maintenance procedures. So I get this email notification, and it notifies me that my line requires a little bit of attention. So what I'm going to do next is log on to AVEVA Insight. For those of you who've used AVEVA Insight, this might be a familiar page for you. But what's interesting is with AVEVA Insight, it's personalized the screen for me. The power of AVEVA Insight is that it's intelligent, it's smart. It keeps track of what you have analyzed and what you've seen in the past, historically speaking. So what tags and what information do you typically spend your time on and you typically analyze more than others? I, as an operator for line 1, have previously and historically spent a lot of my time analyzing data in AVEVA Insight from, of course, my line 1 operations. So AVEVA Insight has personalized this homepage for me, and it's given me information for line 1. So as you can see in front of you, this graphic right here is indicative of the performance of my line 1. It gives me a good visualization of how my line is doing. It also gives me visualization of certain assets that may require my attention in line 1, of course. And of course, it gives me a quick view of just some basic information that I would find useful. So that's on the left-hand side, but on the right-hand side, if you notice, there are certain trends in dashboard formats that show me that some values seem to be deviating from the norm. So for example, AVEVA Insight on its own identified certain values that are behaving in a manner that they have not behaved historically. So for example, the OEE was higher than usual. This can be indicated and can be seen from these red values right here. Historically speaking, the values are not nearly as high as what we've seen in previous history. This is OMI newsfeed. This is that newsfeed solution in play. Like Justin mentioned, no configuration is needed from the end user. AVEVA Insight does this automatically on its own by doing some basic algorithmic identification of previous historical values, this AI that's coming into play. What I can do with Insight is I can personalize the screen even further. I can provide feedback to AVEVA Insight with a thumbs up and thumbs down icon. So I can give it a thumbs up if this information is useful to me and I want to see more information, more data like this. I can also give it a thumbs down icon if I don't want to see information like this. So really, it's a great way to personalize the screen so that I can get more useful information quicker that's important to me. I can also personalize the dashboard further. I can use this Google-like search feature to search for more tags and more information that I want to see. So, for example, if I want to see additional pump information, I can search pump. And Insight does not just give me data tags that have the word pump within the tag name. It also gives me keywords, data that may be affiliated with pump, information that you see in front of you in this drop down below. You have the flexibility of adding whatever tags or whatever information you want, and that information could be added into another dashboard, again, personalizing for you. So this is the AVEVA Insight homepage for you, but of course, going back to the whole reason that I decided to log into AVEVA Insights, I was given an email notification that there was something wrong, there was a fault with my line, with line 1. So what I'm going to do is I'm going to go ahead and click on the graphic to take a look and see what's going on. I go ahead and I click on the graphic. And what I see in front of me, again, is a visualization that helps me identify and gives me a visual aspect of how things are going with my line. Again, more important than ever as we begin to work more and more remotely, just to give us a basic idea of what exactly is going on the ground floor if I'm not there. So this is one way to view some data and basic KPIs, but with Insight, you have capabilities to view data in different formats. So from the gallery, I can go in and I can take a look at the data from a status board, almost like a current value table that'll show me the current values as well as the trends and the behaviors. I also have the capability of looking at the data through a column chart. Again, this is just data through a bar graph, and I can also manipulate the data statistically speaking so that the data can be in a format that I prefer. Finally, I also have the ability to view data through probably one of the more common ways that we see data, through basic and traditional trends, through line charts as we see in front of us right here. AVEVA Insight has went ahead and trended some of the bigger tags that require my attention, that data that I've seen before, and I can go in and I can analyze as I see fit data for my line. However, if I wanted to, I can also add individual tags that I think are important to me, or I can take them out. So if I wanted to add them, I would click on some of the tags that are not available. If I wanted to take some of those individual tags out, I can just click on one of the colored ones, and that would take out the data. So there's a variety of ways to personalize and trend and view the data. But what I can also do is I can add an alert with this bell icon right here. This is where the conditional monitoring comes into play. This is where I can actually create a rule, and that rule will be triggered, and I can automate certain actions that are going to be taken once that rule is crossed. This is the conditional monitoring. That's how I got the email notification initially. So to start things off, it's asking me to define some triggers. It's going to ask me to define certain tags that are going to be the reasons, the causes that my rule is going to be triggered. It's going to take place. So it's went ahead and given me all 5 or 6 tags that were originally on my trend, and that's pretty powerful. With condition-based monitoring, you have the ability to make a rather complex rule that can be multivariable based, so it can be as complex as you want it to be. Now, for myself, I want to create a rule that is based off of that is going to describe for me how my line is doing. So I want to create a rule that's based off of 2 tags, my availability as well as my downtime. So I'm going to go ahead and I'm going to delete the tags that are not important to me at the moment. I'm left with the availability tag and with the downtime tag. If my availability is less than 85%, and if my downtime is greater than 10%, those are the triggers on which I want my rule to take play. If these 2 triggers at the same time cross those individual thresholds, then I want my rule to take place. So now that I've defined my triggers, I can go in and I can define my actions. Again, this is the powerful part of CM, where it's not just about email notifications. You have a lot of flexibility and power to do what you see fit. So the first one, of course, is sending me an email notification, which we have already seen. The rule is going, if when triggered, is going to send an email notification to myself. I'm also going to initiate a safety permit. I'm going to initiate a maintenance work order as well as a work request. And those are the actions that I've defined for my solution. So there's a lot of power. You can create work orders, work requests, safety permits, send notifications, et cetera, and so forth. Finally, what I want to do is just give it some descriptive information. I'm going to give my rule a name, and that's going to be in the subject line of my email. I'm also going to be giving a description as we see here. and that's the completion of the rule. So we've taken a look at this data and we've created a rule, and that's how we were notified of the original issue with the line. But let's think about this further. We still have not identified the potential faults. What exactly is causing my line to be going into unexpected downtime? Well, we can do that by analyzing the equipment efficiency. So I'm going to go and I'm going to navigate to the equipment efficiency screen as you see. And so now what I see in front of me are information, KPIs that describe to me what exactly is going on, what's causing the downtime that I'm seeing. So of course, I'm looking at analyzing line 1, so I'm going to click on line 1. Now what I can do, as you can see, the red regions indicates times of downtime. What I can do is I can change my display so that it's at 12 hours, which is what I've done right here. And now what I can do is I can hover over the regions of red, and I can see what's been causing my downtime. And as I can tell, I'm seeing a few pump overloads that are causing downtimes. Again, we just saw another pump overload. We hover to another red region, and again, we see another pump overload. So we can clearly tell that pump overload seems to be a big contributor to those unexpected downtime operations in my line. I can analyze some individual and some additional KPIs, and I notice that of the top 5 downtime reasons I'm seeing by count, pump overload seems to have more than any others. I can also scroll down and take a look at it from a duration perspective. Again, pump overload in my in the last 12 hours seems to have contributed the most amount of downtime. So we have identified the issue with the line. We've been notified of it. We also have identified the asset that is responsible for the downtime that we're seeing. So it behooves us to try and figure out what is wrong with my pump. Why am I seeing the issues that I am seeing with my pump? Can I predict impending failures? Can I try and reduce that unplanned downtime? Can I resolve the issue before the pump completely fails? Can I diagnose the issue? Can I see what's going on? Why is he seeing the failure with the pump? Well, we can do all of that with our predictive analytics solution, which is what we're going to be jumping to next. So this screen should be familiar. You saw a screenshot of it on Justin's presentation. This is our predictive analytics screen. And again, this is typically the first page that our operators or me as an operator would log on to when I start using my predictive analytics application. So I would log on and I would take a look at the alerts homepage, the alerts page, which is what I see in front of me. Now, something to note, on the left-hand side, you see an asset hierarchy. This is very important. This is how we're able to scale. We have customers that have tens of thousands of assets and are thus modeling tens of thousands of assets with our predictive analytics solution. The solution is able to scale and scale well as it grows because we're leveraging an asset hierarchy. You can actually take this asset hierarchy from your EAM system. We can copy it over. We can transfer over that data and classify models under each hierarchy. We can also restrict information based off of the hierarchy. So I can expand and I can contract the hierarchy so that if I'm only in plant 1, I only see what's in plant 1. If I'm only in plant 2, I only see what's in plant 2. Now, something to note, I see the entire asset hierarchy in my demo environment, and I see all the models in my demo environment because, of course, I'm an admin. And so I see everything. But in the real world, as an operator, I would be restricted, and I can be restricted so that I only see models and hierarchies that I am responsible for. So if I only want to see plant 1 or line 1 or whatever it is, I only need to see that, and the admin can configure and personalize my screen so that I only see information that I myself am responsible for. So we've went ahead and we've taken a look at just how the hierarchy is managed, and we take a look at how all the models look. We're going to revisit the screen in a little bit to talk about alert management in a bit, but we've taken a look, and now we want to take a look at the issue with the pump because that's what brought us to our predictive analytics screen. In this case, we are going to diagnose and see what is going on with my positive displacement pump, which is what's available in my food and bev plant. Positive displacement pump, of course, a common pump in both food and bev as well as water and wastewater. So if I were to click on this link right here that I'm hovering my mouse over, this is a link. This is what I would see. So this is the individual analysis of the positive displacement pump. Again, a familiar screenshot. Justin had something similar in his presentation. The first trend that we want to take a look at and that we want to pay attention to is this trend over here that I'm hovering over with my mouse. This is the overall model residual signal. It is a summary signal, a summary trend of sorts that's displaying to me how much my asset as a whole is deviating from the norm. And again, this deviation from the norm, this basic deviation, that's your early warning indication. That's where we are trying to get you weeks, months in advance notification of an issue so that you have enough time, so that we have enough time to diagnose and resolve issues that we're seeing with our positive displacement pump prior to multiple failures that are occurring. So this is the summary signal. I can scroll further downwards and I can identify and I can monitor individual signals. Again, these are individual mechanical signals that describe my pump, pressures, temperatures, etc., and so forth. Again, this is information that we can take from our historian, we can take from AVEVA Insights, and we can take from other historians that are within our solution. If you notice, each of these signals, each of these trends has two lines, has two individual properties. So if we hover over them, we notice that there are actual value trends, which are in black, and predicted trends, which are in green. Every single one of my signals has these trends. It might be hard to identify, but they are there. Here's what's important. The actual value signal, that's coming directly from your historian. That's describing what your asset is doing right now, here and then. The predicted signal, which is in green, is generated by our machine learning, by our AI, by our predictive analytics solution. This is a real-time generation, a prediction of what your asset should be doing if it's operating normally and ideally. We are able to, in real time, generate this prediction of normal behavior because this is a model-based solution. We leverage historical data and we build a model based off of historical data. And by leveraging that machine learning, we can generate this real-time prediction. This deviation between the actual and the predicted, this deviation between the black and the green, that's your real-time warning. That's your early warning indicator that weeks, months in advance notification that, hey, we are seeing a deviation from the norm. It looks like it's growing bigger. Take a look at this issue before the issue becomes catastrophic. So that's the early warning notification that the solution is trying to display to me as an operator for this positive displacement pump. We do not just stop there. What we can also do is we can click on signal contributions. So going back to the OMR is telling us how much my asset is deviating as a whole. I can click on signal contributions to see which of my signals is contributing most to that deviation. And this is a powerful tool because it enables us to quickly see who's the bad actor. Which of the signals is the biggest deviator from the norm. And what that enables us to do is we started off with maybe thousands of tags in our historians. We built models. Now we're able to simplify to a simple signal by signal basis to see what exactly is the culprit. Is my pressure higher than normal? Is my temperature lower than normal, et cetera, and so forth. So as you can see, we can hover over them and we can take a look at some additional information. But in addition to signal contribution, what I can also do is I can click on here on the red icon and I can take a look at my prescriptive actions. This feature is known as fault diagnostics within the solution, but it's our common failure mode analysis. This is what enables us to leverage and generate an estimation, a diagnosis of the problem that you're seeing. So I, as an operator for my plant, for my line, for my pump, I know that there's a problem. The solution has given me a warning of an impending failure for my positive displacement pump. However, why am I seeing the issue that I'm seeing? Well, with our predictive analytics solution, we have the ability to diagnose, further diagnose, and prescribe the issue that it is that we're seeing. We're able to do this by leveraging our templates, by leveraging our connected content. So our template for our positive displacement pump will have information such as common failure modes, that the displacement pump will typically see. But it doesn't just have common failure modes, it also has symptoms of those common failure modes. So the solution will start monitoring for and predicting deviations, but it'll also try to look for symptoms of those failure modes. And if it finds those symptoms, it'll generate and it'll present to us what it believes is the biggest indicator why we're seeing that deviation from the norm, what issues is contributing to that norm. So as we can see in front of us, the solution has determined for us that the three biggest probable causes of the deviation of the issue we're seeing in our pump is a binding rotating element, increased liquid viscosity, or over-tightened packing. Looks like the most likely scenario could be a binding rotating element of the 3. So what I can do is I can click on that binding rotating element and I'll get additional information. I can get a description of what exactly the issue is, whether it's maintainable or not. I also can get prescriptive actions. I can get next steps so that I can take a look and verify what can I do to further resolve the issue that I'm seeing. So the solution gives us steps to try and resolve the issue. We can leverage that information once we submit those work orders and work requests. And so that's the information that we see in front of us here. Great. So that's the analysis that we've done. So the solution has enabled me as an operator to see if there's an impending failure for my pump so that I don't encounter unexpected downtime anymore. It's also given me some diagnosis and prescriptive actions of how to resolve the issue. So what can I do next? Well, I can leverage my alert management and alert workflow so that I can classify the model appropriately. So I can go in and I can click that green check mark and highlight that my model. I can clear the alert if I want it to. And if I were to clear the alert right here, then what would happen is that I would take that model completely out of the dashboard, out of the screen, and I'm no longer notified of the issue. But what I can also do in addition to clearing is I can give it different states. I can classify the alert under different states based off of what is the appropriate behavior that it is displaying. So if it was a sensor issue, I can get it classified under sensor issue and send that model and send that issue over to my historian admin as an example. But if it's an equipment issue, I can go in and classify it under the wrench, which is what we see here. And again, all these states have different, represent different states. All these different icons represent different states as you see in front of you right here. So I can classify it under equipment issue if that was an equipment issue and then forward it over to the appropriate operator as we see fit. And again, we can assign this alert, we can assign this issue to different people within our organization. So we went ahead and leveraged our alert management, alert workflow. Finally, we can go in and we can leverage our case management. Again, a screenshot of this was shown in Justin's presentation. We can leverage our case management solution as a great place for knowledge repository. It acts almost as if a basic work request case where you can open up a case for the issue, you can add discussions, and you can add resolving information. And the power behind this case is once the issue is resolved, once the case is closed, you can go in and you can search for this issue in the future. The power behind this being that if this issue may be encountered in the future again, you can search for it again and you can find what was done to resolve this issue in the past relatively easily. So you can do that with the search icon, but what I can do is I can open up each individual case. And as you can see here, I can add information such as titles and descriptions. I can start a discussion. What I've done here is a user has went in and actually in a discussion implemented and put in the prescriptive actions that the Predictive Analytics solution has recommended for us. The power of it being embedded within our Predictive Analytics solution is that we can link the model directly to this case. We can also add resolution information as you see here. We can add value information and impact, what type of fault it was, et cetera, and so forth. Again, we can assign this case, if you follow my mouse, to different users. Let me just zoom in. That might be easier to see. Yep, you can give a case state. You can give it a priority, so you can raise the priority to escalate it if you see fit, give it a category, and assign it to different people. So that's the case management solution for you. So up till now, we have shown you the capabilities of the Predictive Analytics solution, how to monitor it, how to manage, how to diagnose, and how to troubleshoot. But now what I want to do, kind of as a final section, I want to show you how the sausage is made. I want to give you the capability to take a look at how to basically very quickly build a model. So what I do is I navigate to the second interface of the application. We have two interfaces, the thin client on web-based, which is what we use to do all that analysis that we did. But the thick client is what we use to build the model. So if I want to build the model, the first step, of course, I want to build a model for my pump. I'm going to build that model with historical data. It's a model-based leveraging historical data. So what I can do is I can zoom in just quickly. I want to import historical data. Let's pause here. As you can see, when I import data, I have a variety of options from which I can import data from. The solution In addition to being equipment agnostic and industry agnostic, we have leveraged the solution in power gen, in oil and gas, in food and bev, in water, wastewater, a variety of different places, as Justin mentioned. In addition to being industry agnostic, we are also equipment and data agnostic. So we can import data from a variety of different historians and connection protocols. Obviously, AVEVA Insight is one popular option. We also have eDNA and our enterprise historian. We also have ODBC connection protocols if your data is in an orthodox manner, such as a database. We also have support CSV and OSI Pi. So what I can do is I can import data. I'm going to import it from a file, a CSV file. I can add files to import. I will select the training data on which I'm going to build my model. I'm going to select Open. And it's went ahead and it's imported the data. So just quickly, we can take a look at the tags that I've went ahead and imported. I can go in and the data has been imported. And it's went ahead and changed and it showed me those tag names. You see them right here. So what I can do next is I can click and I can trend this data. Now, something that you may notice, which is this data is not perfect. In fact, it's got quite a few dropouts to zero, as you see in front of you right here. And I see this all the time in my experience of working with historians in predictive analytics. Historians are not perfect, and that's totally fine. Historians tend to encounter issues such as network latency, et cetera, and so forth, which could cause maybe these brief dropouts to zero. Thankfully, we can easily clean that information with our predictive analytics solution. So going back and zooming, actually, let me show you one more thing. Let's just keep going through the video. We can click through different signals, and we notice that a lot of these signals have those dropouts to zero, which are indicative of bad behaviors. We don't want that in our model. So I can pause, and what I can do here is I can go in and I can actually select from this radio button what I want to do with my data. So currently it's selected to zoom, and what that means is if I drag and drop over a certain region, it'll just zoom in on that data so that I can take a look at it in more detail. What I can do instead is I can select that data, which is what I'm going to do. And now what it's going to do is when I drag and drop over those zero regions, which is what I'm doing with my mouse, it's highlighted those regions that are indicative of bad behaviors. Now, of course, it's highlighted them, and the easiest region to see is this yellow region right here. If we zoom in, we might be able to notice that it has zoomed in on all the other signals as well. It's a little hard to tell sometimes because that dropout only occurred for one value, and we're looking at data over the course span of a year. But rest assured, it's highlighted. Now, what we can do is we can zoom back in here, and we can actually delete the data. As we can see here, we're deleting. And that data has been taken out. Notice how the range was from 8,000 to 0 for this for the flow. Now it's from 8,000 to about 3,000. I can take a look and select individual tags as well. And I notice that the tags, if you had a good eye, you notice that all those tags had dropped out to zeros. But since when I took out the data from the discharge flow, it also took out those dropouts to zero from all the other signals as well. This is deliberate. When you take out data from one signal, you are excluding that entire timestamp from the data set. A really easy and quick way to enable you to quickly clean and build your model and build your data and clean it quickly because you're taking out dropouts from one signal, you're taking out dropouts from all the other signals as well. So we can take a look and we can notice a lot of data. We have additional capabilities to build our models as well. We can implement filters, which are on and off switches for when our assets are in outage, et cetera, and so forth. But going back to Insight, so we've learned how to build our model. That's really a basic overview of how the sausage is made. But going back to Insight, we can go in and we can, we've went ahead, we've resolved the issue, we've diagnosed the issue. Now we can go back to Insights and leverage our predictive analytics solution to add a journal entry to resolve the issue that we just saw. So I searched for the bottle line again through the search menu. Again, quick and easy way to do that. It's like Google. Under Asset Actions, I can add a journal entry. I can add a title, what was done to resolve the issue, and this is all information that will be available to the other operators. So from beginning to end, I was able to leverage my tools to look at and analyze the data. I was able to analyze my line with Insight and the capabilities. I was able to identify the cause of the issue, the pump. I was able to diagnose, predict, reduce and get a warning of an impending failure of the positive displacement pump with predictive analytics. I was able to diagnose the issue and prescribe. I was able to resolve the issue and finally add a journal entry. And this concludes my demo. Thank you so much, everyone. Really appreciate it. And Katie, I will hand it back to you.
Great, thanks, Omar. I'm going to just share here real quick. There we go. Great. So while I'm doing that, I need to open our poll. I'm opening our poll. If you wouldn't mind answering our questions that we have here, that would be great. Did you find the event informative and a good use of your time? Do you plan on attending any of our other ones? And if so, how many? The poll will stay open for about 5 minutes. And while we're doing that, feel free to utilize the Q&A or chat box for any questions that you may have. And we'll be happy to answer those in just a moment. If I can find the Q&A button. There we go. Sorry, folks. It changes my view every time I open something else. Okay. So like Aaron said, we do have successive events happening over the next few weeks on Fridays at noon, and we welcome you to register for those and attend them. And we encourage you, even if you're unable to attend them live, to please feel free to register, and we will be sending you the presentations after the fact. So even if you aren't able to attend, but you're interested in the topic, please be sure to register for that so that we can send you the information so you can review it at a later time. And if you guys have any questions beyond what we've learned here today and beyond our session, we'll keep the questions open for a few more minutes. But if there's things that you wanted to talk about specifically with an account manager or with InSource technical support or something like that, feel free to contact us and we'll be happy to connect you with the right people. So I do have a question here. I'm going to make sure before I do this, I want to make sure everybody's unmuted. It's giving me a weird view now. Sorry. Here we go. Let's see. Okay. All right, Justin and Omar are muted. So our question is, how much data would be required to effectively train an equipment model?
That's a great question. I'll take that one. So traditionally, what we've done is we've taken about a year's worth of data, and then we don't need that high frequency. So it can be years worth of data, maybe once an hour to train that model. However, if that amount of data is not available, we can work with less amounts of data. So if you only have data for a couple of months, we can build a model with that data. We might up the frequency a little bit to maybe once every few minutes to build a model, just so that we have enough values. If you do not have data, meaning you or your customer are just slowly starting to implement the historian, well, what we can do there is we can start building a model with what data you have, and then as you begin to collect more and more data, we'll have the model, the solution learn as more data is collected. We have the capability of easily letting the solution learn additional information until you have enough data to comprise a good model.
Great. I have another question that's also related to the data. I might have missed this, but when the system learns from historical data, how do you tell the system what is baseline versus issue in the past?
Yeah, that's a great question. It comes down to the user. What you do not need, and it's a very user-friendly solution. You do not need to be a data scientist to use the solution and build a model, as we just displayed. But what you do need is a certain level of proficiency with the asset from which you are building your model. So there's an expectation that the engineer who is building the model for, say, the pump would understand and has a history of the pump and knows which data sets were indicative of a failure or of abnormal behavior. And so the user would exclude that data in the same way that I just excluded those dropouts to 0, such that the only data that remains is data that indicates when the asset was operating efficiently and ideally.
Okay.
And can you hear me, Katie?
Yes, absolutely.
I just want to add to that a little bit. That was good answer, Omar. Just a couple things. One is to keep in mind that there's always the DCS upper and lower thresholds, or the CBM tools that you have, maybe using your historian, that have an upper and lower threshold. So we know for sure that any outliers that are above and below those thresholds, definitely you remove those, right? So that you don't need to know much other than what are the thresholds from the DCS, right? That's one way also to consider when doing that. So that's just another level of specificity there.
Great. All right. Again, please continue to enter your questions into the Q&A and chat box. And we have a few more here. One of them is, I was thinking that automated reason assignment already existed for downtime and insight. Did I hear the presenter say that it's in a future release?
Yeah, so I think what we're getting to here is that when you enter in, like when an operator would enter in the reason code and the time, that's manually entered today, and then that's recorded and recorded over time. I guess in the future release we're talking about is the way to automatically get those downtime and reason codes imported in.
Okay. Is the common failure library included with Prism?
Yes, so what happens is Omar demonstrated so let me describe it in two different ways. We've got the fault diagnostics that's associated with Prism, right? So you get the anomaly and then a potential fault diagnostic. There's prescriptive actions that are associated with it. We've built those into the templates. Going forward, however, it's going to be part of what we call our connected content. And so that is going to be a licensable feature going forward. So it has been included up till now, and now we've gotten more specific with the ASL Asset Strategy Library. So if we're just talking about Prism specific fault diagnostics, then it's included. If we want to get all to the rest of the maintainable items in the plant, then you pay extra. So there's a it's distinguished there, right? So when we go beyond what's just native into Prism, then you have to pay because there's thousands of maintainable items that are in the plant that may not use predictive analytics.
Okay. So that looks to be all the questions we have in the Q&A and chat box for now. Again, I want to thank our presenters, Justin and Omar. We appreciate you guys helping us out here today and giving us some really great information. With that, I'm going to end the session. I'd like to say thank you to all of you for attending, and we will be sending out an email follow-up with the recording later next week. Should you have any other questions or would like to speak with someone at InSource, please feel free to contact us. You can either contact us via our website, which is insource.solutions, or you can email us at communications@insourcess.com. So thank you once again and have a great day.